Good morning.
Hi.
Hey.
What did we do on Wednesday?
A bunch of stuff. Do you know where to find the class recording?
Yes, I do.
Okay, you're gonna need to watch that.
Alright.
If you just pull up the class website, you can see the agenda. The agenda's on the top right of the website, and you can see the handouts that they got.
Mm-hmm.
And then any extra handouts I have, I put in that bin over there. The one that's on the chair.
Yeah.
So you just need to know the numbers that they were. Looks like 14 and 15.
Got it.
One of the things you missed was the memorization quiz, and I should have you signed up on prime time for Tuesday to make that up.
Got it.
Or I meant to, at least.
If you did, I'll make sure to sign up anyway.
Well, I started closing my sessions. I don't know if that's going to how that works.
Like closing to just your classes or what?
Well, I don't know. I think closing means closing it to just students that I have,
Yeah.
but it may make it where you can't sign up unless I sign up. I'm not sure, because it's all new
Other
to me.
teachers did that, she went to our only like for advisory classes.
That's what I intend.
Teacher, I need to leave early for a band today.
Okay, I'll have to check in teacher announcements, but just what time is it supposed to be?
I need to be there at 9:30. So
I gotta leave at
Because people get hot.
like 9:25
For whatever reason.
to be at the band room at 9:30.
Okay, 9:25. I'll still need to double check at teacher announcements, but at 9:25, just remind me, or a few minutes before that, so you can actually be out of the room by then. Yeah, 9:20. It says 9:30, but 9:25 is fine. Oh, weather's all over the place. It rains and then it'll be hot. Sometimes we got a lot last year. Yeah. Got a little wet. A little bit. I didn't bring that. You guys do need to get out that book assignment to make sure you don't have any final questions from that. So while you wait for the tardy bell here, that would be a good move. So try and read. Okay, we've got a small handful of things to do today.
Good morning, FHN.
Okay, I guess that's not coming through the speakers. We got a small assortment of things we need to take care of today, but the first of which is the book assignment that I asked you to finish up for homework. So I know I have all of those worked out as videos on my website, but occasionally the video is not enough or not what you needed. So I'll try to give you one last chance there. If there's something from that 4.3 book assignment you need to ask, your chance is going to be just in a moment. But while you finish getting that out, the other things we're going to do today is we kind of need to tie up all of our 4.3 stuff. So the first day we saw it, we took some notes. I told you how it's kind of in two halves. The second day we looked at it, we practiced this book assignment, number 13, which was a bunch of SOHCAHTOA practice. SOHCAHTOA ratios, SOHCAHTOA, side lengths from SOHCAHTOA equations, angles from SOHCAHTOA equations. And then last class we practiced some trig identities, which was the other half. So today I need to make sure I've got your book questions answered. We're going to go back and spend some more time on that handout from last class, number 16, because it is a little bit longer and I didn't ask you to do it for homework. I suggested that you do a few to make it a little bit quicker today. All of those are ready to be turned into Google Classroom. So as you're sure those are finished and ready to get full credit, you should turn those in. And then finally, I like to give out the test review a little bit early. So our test is not next class. Next class is just a 4.3 quiz. But from this test review, there are some things that If you do them before the 4.3 quiz, it's kind of two birds, one stone, because you're getting a little more practice on 4.3, and then you also have part of your test review done. So the questions that I think apply to section 4.3 are listed up there on the agenda. That would be 1, 2, 3, and 4, the front page, and then all the way on the back, number 19. So I'm only pointing that out to you at the start of class because I know some of you are closer or have no questions on your book work. You're closer to being finished on number 16. You may have already turned in your assignments or most of your assignments in the Google Classroom. So to make the best use of your time, I want you to know what's coming up after that. Okay, any questions about the plan this morning before I slide the screen away? All right, Ryder, I have no idea what you're working on there, but definitely not the right thing. Okay, so 4.3 book questions. Again, I know you basically had a full class period where I went around and helped a lot, and we did one of each. And I asked you to do it for homework, and there's the videos on the website. But after all of that, what questions did you still have issue with or struggle with? Also, one other thing I do want to point out. Our first two sections, we did practice quizzes. So 4.1 had, I think we did 2 practice quizzes there. 4.2 had 2 practice quizzes. 4.3 is the first one that we don't give a practice quiz for. It doesn't mean that there's really a surprise on the quiz. It's the same skills, but you don't get a worksheet ahead of time that looks like the quiz. So as I'm glancing through the book assignment, the same thing that you should do. I remember 5, 7, and 11 were the same type of question. So if there was 3 of those in the homework, there's probably going to be one on the quiz. 15 and 17 were the same type of question, so there's probably one of those on the quiz. 23 through 28 were the same type of question. 38 through 40 were the same type of question. 53, 55, 57 were the same type of question. All of those, especially if they're questions that were on there multiple times, you can almost guarantee that they will be on a quiz. So part of your studying needs to be looking at when you did question 5, 7, and 11, were you able to get the answer right? Is it one that you marked? Is it one that you made a note for? Is it one that you need to review? If not, great. Move on to the next question type. But if it is, then that's pointing out to you what you need to review. So, okay. So, what book questions were you unable to complete, if any?
What's the vocab for 4? Do you know that?
The vocab for 4 says an angle of blank represents the angle from a horizontal line measured upward. That's called an angle of elevation. And whereas an angle of blank represents an angle from a horizontal line measured down, and that would be depression. That's vocab check number 4. I'm not really sure why they put that there because I don't think you needed it in this assignment. Maybe for one of the word questions or something, but we'll do more with angle of elevation and depression later on. Okay, others?
Go over
40?
40.
Okay, so if you don't need help with 40, that is perfectly fine. But I shared with you the 3 or 4 other things you're going to be doing this period, so you should be doing one of those if you didn't need help with 40. Okay, so with question 40, again, it's not multiple choice, it just has multiple parts. I'd say only one of these answers should be pretty quick. If you know secant, cosinus is reciprocal. The others, especially this one and this one, you need to do some other work for. But this would probably be either the most missed or the second most missed type of question on the quiz. And I get that it looks different, but it did show up a couple times in your homework. It is something that we ask you to memorize. So this is one of the cofunction identities, and that says that the cotangent of 90 minus theta, or pi over 2 minus theta, is the same as tangent. That's one of the cofunctions we ask you to memorize. So as soon as I figure out what tangent is, it's the same thing as that answer. Now, to move forward on this question, this one and 39, to me these look a lot like questions 15 and 17. They gave you a trig ratio. I'm going to look at this one. So within that trig ratio, you could set up a triangle, a right triangle. If you know cosine, you can label adjacent to hypotenuse. That doesn't mean the length is 1 and 5. The lengths could be 2 and 10 or 3 and 15. It's all proportional. But for every 1 in length here, there's 5 in length there. And then now with this visual, it's like question 5, 7, and 11. You could do Pythagorean theorem. Take the square root of both sides. You do have to sometimes reduce your square roots, and there's a couple ways y'all can do that. If we need to review that together, we can, but looks like it is 2 square roots of 6. And now that I have all 3 sides, any SOHCAHTOA ratio should just be a matter of pulling them out of our picture here. Cotangent would be adjacent over opposite. That has to be rationalized. This is the same thing as tangent, and tangent's opposite over adjacent, and sine is opposite over hypotenuse. But the 2 big keys to this question is, a lot of people, if you leave these blank, it's that you're not taking this information and making a picture out of it. Again, sometimes the picture's made for you, sometimes the picture's not made for you. This is where it helps to review, even if it's just 5 or 10 minutes. And then also, even though it would just probably be 1 point, realizing that this is the same as tangent. That's the cofunction identity, one of the few we ask you to memorize. That's the only way to work that question. If you're trying to reason through this in your head and make sense out of this in any other way at this point in the year, you're not going to get that. You have to have those memorized. Okay, was that enough on 40? Anybody else that was going to ask about 40 need more than that? Again, I know I've been pushing you guys to do this all year, but now hopefully you'll start to take my word. When you do these questions, you know, whatever it was that was your roadblock, or you know, you had to ask for a hint or look at your notes. Like for me, most people probably need to highlight this as a picture. Give yourself some kind of representation of how was it that you moved forward. Because I want you to look back at this assignment to study, but if you don't have that and you're just looking at numbers and you don't remember where you struggled, then it may not help. So, your homework is good practice, but it also needs to be a document that helps remind you of the things you need to look over a second time. Okay, anybody else? Book questions?
You go over 68.
I took 68 off the assignment. You don't have to worry about that one at this point. I'll tell you the fast version. I'm not going to go through the whole question, but the only reason I took it off is because in January we do law of sines and law of cosines, and it is a much more efficient way. But really in this question, you've got a small right triangle. So if you make one SOHCAHTOA equation with the small right triangle, and then you've got a big right triangle, if you make a second SOHCAHTOA equation with that, you end up with 2 equations with 2 unknowns, And so you can solve those like a system of equations. If you guys remember doing things like, I don't know, solving stuff like this in algebra class, that's essentially what you get. If you set up two SOHCAHTOA equations, you get a system of equations that you could solve. Again, and it's just not that important. You should be able to solve a system. You should be able to set up both SOHCAHTOA equations. We've always asked students to do it, but at this point in the year, it's just not a high priority. So you do not have to have that one completed on the homework. Okay, then sounds like we need to all be, where are we at? These trig proofs from last class. Not this one. This one. Okay, at the bare minimum, you should have the front page finished, except for number 8, which I suggested maybe trying at the end, because it is typically the hardest one for people. And I think you guys probably tried a few of the questions on the back page, but take a couple minutes and pick one you haven't tried yet and start it. And I will try to balance here, give you time to think about these and try some of these, since I didn't give you enough time to try them all, but also enough time to help you and go over them. So pick one. Start. Lucas is not here today. A lot to do. Well, because this one's over sine squared now. You can only, you can think of this as a fraction as putting it over 1. But the only time you can add a fraction is if they have a common denominator, and they don't have a common denominator. Again, on this back page, you pick, jump around. If you have no idea how to start question 10, but number 11 looks easy, then do number 11 first. Knock out the easy ones, or the ones that are more obvious to you, and then kind of pare down what your focus needs to be. So even though these type of questions will be on our 4.3 quiz next class, I believe the quiz only has 2 of them, so it's only like 6 of the points or something. Not nothing, but also it's not like a ton of the points like this on the quiz. We usually come back and practice this skill again before the end of the semester. Usually a little bit easier the second time you've seen it. brains somewhere else.
These two do have the same thing on
Okay,
it.
so you can.
If I had them together, it's not, it's fine.
They go over the common denominator. When you have things with a common denominator, you add or subtract the numerator and put it over the common denominator. You don't also add the denominator. Okay, let me help out with a couple. Again, it's kind of rough because I'd really like you to try a certain question before I talk about it. But if you have not tried number 11 yet, I think 11's not too bad. I think you can do 11 in probably 2 steps. So glancing at some of the papers as I went around, I didn't see many people notice, but what happens if we take sine squared plus cosine squared? What is that equal to? It's 1. That's the first Pythagorean identity. So just because they're not next to each other, they're still being added, so you can still make that substitution. And at the top of your page, if you have all 3 of them written down, like my suggestion, then you're also going to see this one, and it says in place of 1 plus cotangent squared, you could put cosecant squared. So it was really just 2 Pythagorean identities. The first one, the terms weren't next to each other. I tried to do that in red to help you see. But sine squared theta plus cosine squared theta still equals 1. And then what was left over was a second separate Pythagorean identity. Not saying that's the only way to do that, but I really doubt that you can do it in less than 2 steps. So, okay, and let's maybe look at, that looks similar. How about question 13? And then I will help more individually and just come around the room. All right, now this did not come up last class, but this still is an algebra skill that you have, or should have. When I look at this, I see the difference of two things being squared. So we could factor this. The thing being squared over here is cosine squared. The thing being squared over here is sine squared. And the difference of two squares always factors as a plus and a minus. So if you don't remember how to factor the difference of two squares, you need to review that. Okay, that should make this part pretty easy. Cosine squared plus sine squared is going to be, okay, and 1 times anything is just that thing. So it's not that it really goes away, but multiplying by 1 doesn't change anything. And now to me this looks like one on our first worksheet we did last class, where I've got cosine squareds and sine squareds, but I only want cosine squareds. So if I want the cosine squareds, I'm probably leaving this one alone. But I don't want the sine squared, so I need it to go away somehow. So using the first Pythagorean identity, it looks like sine squared is the same thing as 1 minus cosine squared. And then distribute and combine like terms. Distribute the negative and see that you've got 2 of these. So I guess one unique thing, although any algebra stuff is really fair game, but I started off with factoring the difference of 2 squares. I don't remember the number. I think it might be number 16 that is also factoring the difference of 2 squares. Yeah. I think if you do that on 16 as well, that might help. Okay, so let me move out of your way again and let you try to absorb that and try a few others. Well, what part of it? Pick one. Okay, what'd you try? Okay, so you changed everything to sine and cosines. I don't see any issue with that. You change it to 1 over. Carry down your minus 1. And then 1 over cosine times 1 over cosine is up to what? Okay, so write that step down. Carry down your minus 1. What's a different name for 1 over cosine squared? Okay, change it to secant squared. And if we're looking up here, secant squared minus 1 is tangent squared. So you did all the steps. I didn't tell you what to do. Okay. What about a different one? You got one?
Maybe 4.
Well, the first thing, you see how I saw this was the difference of 2 squares and split that up? Factor that as the difference of 2 squares. Factor that as a sine squared minus 1 and a sine squared plus 1. See how far that takes you. Well, 14, you got 2 terms here and 1 term here. So I would try to add those 2 together. So try to get a common denominator so that you can push it together in one direction. I think that you can pull that off and it would be pretty close. You want me to done them all? You got one that can help you be unstuck with? Any hints over here I can give? Any that you tried and got nothing? Here, is that a plus one? Well, it's all over cosine squared still. So we don't want to, what I would maybe do is if you think of the first Pythagorean identity, well. Let me do that one first. Okay, I'm looking at number 16 real quick. I know I gave y'all a hint that I think you should probably factor this as this difference of two squares. But to move forward from here, I don't know. I think maybe one thing that I would try is cosine squared is the same thing as 1 minus sine squared. And the reason why I think I might want to try that is because then these are almost the same thing. And I'm thinking this guy has a denominator of 1, so I probably need the denominators to go away at some point. So if you look at this, do you see how this factor has the exact opposite signs as this factor? This is a positive sine squared but a negative 1, and this is a positive 1 and a negative sine squared. Well, we have one algebra trick where I could factor a negative out of this, like a GCF, which is going to switch those two signs and let those cancel. So it's like pulling out a GCF of negative 1. You can always pull out a negative 1 out of everything. And then I've got negative of this stuff, so let's distribute the negative. Okay, and then I think just like the last one I looked at up on the board, if you've got sine squareds but you want them to be cosine squareds, then use this up here. Sine squared is the same as 1 minus cosine squared. Then if you distribute your negative, you have everything that you need. You have a positive cosine squared. A minus 1 becomes a minus 2. Now, I don't know. That one you might be able to find something more efficient on. But again, that numerator, that fourth power in this numerator doesn't match up to any of my identities, which is why I really want to change that. So changing it into this stuff, it's close to an identity. And then anytime the signs are exact opposites, you could factor out a negative, and then you can get some stuff to cancel. So let me leave that one up. And I'll see what else is holding back. Any that I can just give you a hint on? Two. Let's see what you try. Okay, split apart your fraction. Okay. With you here. I'm not sure what you're doing there though. What is
Change the cosine.
it looks like you have one over sign. Oh, okay, I see what you're saying. Oh, so 1 over cosecant does eventually become sine, okay. I'm with you there. I'm with you once you get down here at least. Okay, this one. Cotangent. Okay, so do you see how you're changing some of this in the signs? It doesn't look like you ever did that with the cotangent squared. Right? Cotangent squared as cosine squared over sine squared. And then multiply it by the reciprocal of cosecant. And then I think the stuff should cancel.
Okay.
The way you do. So try that and see what it is. Again, I'm only trying to give you hints as they come around. I'm not. If we need to do one completely on the board, then I need everyone to see it, so. It's just gonna be sine times cosine. So your work here is looking good. So if you distribute this, you're gonna get cosine minus a sine times cosine. And it should cancel out with something shortly after that anyway, so. Is there one thing you can catch on? What happened to your numerator? I see it on your first step and then it disappeared. Okay, so you're doing times the reciprocal. The problem is you can't just do the reciprocal of this and then slap a plus sign. It'd have to be the whole. Is that your last one? You look like you're close. I'll do the one in word. I'll take two more. That help? I don't see much that you could do to start that one, so I would probably change everything into sines and cosines. Yeah, do cosine over, and then change this to 1 over cosine. And change this into sine over cosine. Well, this big fraction bar is the same as divided, so just leave it as a fraction bar for right now first. Because the secant is 1 over cosine. Okay, and then instead of tangent, we could do, okay, sine over cosine. Okay, and then this is what we call a complex fraction. You've got smaller fractions within a bigger fraction. So what you really want is to multiply this guy by cosine, because dividing by cosine and multiplying by cosine cancels those out. But you can't just multiply this by cosine unless you also multiply this by cosine, which is good because you need to, and this by cosine. So try multiplying all three of those things by cosine. And see what it finds. Okay, let me give you about 5 minutes of work in here, and in 5 minutes try to finish up the one you're looking at, and if you've not tried question 12 yet, try question 12. So hopefully you've tried this question 12 at this point. So to move forward here, none of this really matches up with many of the identities, but again, there's always one thing that you guys can go to. And again, don't try to just do this on every question because you're going to make some questions way harder than they have to be. But some of these questions, you're going to have to change everything into sines and cosines. Tangent is sine over cosine. Cotangent is cosine over sine. And then this is what we call a complex fraction, when you've got a smaller fraction within a bigger fraction. And the way we deal with these mathematically is I really would like to multiply this small fraction by cosine because it makes those cancel. But to keep it balanced, everything has to be multiplied by cosine. And then for the same reasoning here, I really want this divided by sine to go away. So if I multiply by sine, divide by sine, those cancel. But then you have to multiply every term by sine. And when we do that, we're left with a sine times a cosine times 1 on top. And if we peek over to the right, that's a good sign that we're on the right track. But I still need to show how this works out. So down here, sine times sine would be sine squared. Cosine times cosine is cosine squared. But that's the first Pythagorean identity. And that just equals 1. So, if you didn't get any steps, you have to at least change things to sines and cosines. Okay, anything more specific about 12 while it's up there? What I would probably highlight if I was you is change everything to sines and cosines and then show that you multiplied everything by sine and cosine to make that complex fraction go away. That's really kind of the key to unlock that one. Okay, let me come around again and see what other common issues are coming up. Yeah. Sine squared plus cosine squared is 1. Got stuck on?
I was actually trying to figure out the shit. That's what I was working on beforehand. So I was going to work on
Yeah, to me this one looks kind of similar to that one. I bet it's similar.
that's what I was thinking. Just because.
Get all these done? Just 8? Okay. Let's see if I can. Okay, so I'm with you all the way to here, and this is true too, but if you do that, you're going to get stuck. I think if you change this to a fraction by putting it over 1, and change this to a fraction by making it cosine squared over sine squared, then it's kind of like this, where you could add your fraction together, and it forces those two terms to be pushed together into one big term. So, there's only certain ones on here that you need to be real concerned about, like the first 4, and I think the very last question. Like this stuff will be on the test, but it's not going to be on next class's quiz. So. what you're doing there, I think makes sense. You split apart your fraction. I'm with you with what you're doing. If this is the same as this. But another suggestion I'd give you that I think might be a little faster. This looks like one of the Pythagorean identities. So if you catch that stuff was just secant squared, or secant squared divided by secant is going to give you, which is the same as 1 over sine. So that would have been a lot quicker. And you don't have to do it that way. I was just giving you a hint.
How would I split these fractions up?
You do 1 over cosine. Each numerator gets put over the denominator.
Is this? Is it minus 1 or is it 1 plus cotangent? I mean, I get.
I don't. You got to finish your sentence. I don't know what your question is.
Sorry. I thought it was this.
What?
I thought it was 1 plus cosine equals 1 for the first identity.
Okay.
That's not it.
I still don't know where you're at. So do you have a question?
No.
Okay. We have to keep filling it up on that side. It's been like 5 times I've been doing that instead of your work. What did you do? That's true, so that's fine. Okay. Minus the 1. All of that's true and works, and it ended up working, so it's fine. You don't have to do it the same way I did it.
How am I supposed to work out?
Well, you change these to sines and cosines. Let's finish this fraction work. So dividing by something is the same as, dividing by cosine is the same as multiplying by. Instead of writing this vertical, instead of on top of each other, write it left to right. Just do 1 over cosine divided by cosine. Okay, which gives you, straight down your plus 1. Here you're done, or your minus 1.
Oh, yeah.
1 over cosine times 1 over cosine gives you,
1 over cosine.
okay, right track. Okay, so what's the different way to say 1 over cosine squared?
Wouldn't that be like that?
That's squared, is the other one squared? Secant squared?
Minus 1.
That's the squared in there?
Oh, yeah.
Sorry. Okay, and then it's got these written up here, that you can glance at sometimes.
That would also be
You're looking at this, you have secant squared minus 1, this would be secant squared. So you either have a mistake here or a mistake there. Yeah, this should be a plus. I'm looking at this one. These can be squared. Sine squared plus cosine squared. If they're not squared, it's not, it doesn't work. Dividing this by cosine squared gives you this. Dividing this by cosine squared gives you this. And dividing this by cosine squared gives you this. So now that plus will stay the same. Okay. So that was supposed to be. Okay, so now this makes sense. So we look up here, secant squared minus 1 is the same as tangent squared. So you can just throw in a tangent on one side now. So you're close. You just needed to, sometimes when you have your fractions like this, it's kind of the other part to know what to do.
Yeah.
So instead of make them right, left, or right, then it's a little easier to see, changing that and find how it's going to work out.
Thank you.
This side has 2 terms, that side has 1 term, so get a common denominator and add those.
See.
Then your common denominator is going to be 1 whole time might look at this. Adding your fractions, your common denominator to your fractions. Well, what would your common denominator be? No, we're not near the other side yet. This has a 1 plus sign, this has a 1 minus sign. So your common denominator is going to be a 1 plus sign and a 1 minus sign. Two factors, two different things. 1 plus sign and then 1 minus sign. Both. 1 plus sign. So this denominator already has this part of the common denominator. It doesn't have that part. So to include that in the denominator, you have to multiply the numerator by the same thing. This is your denominator. And you're trying to multiply. You're done with your denominator. You're going to you have these fractions. Okay, so between 2 and 3, 6, 6. Right? This denominator is going to multiply by 3, so we have to multiply the numerator by 3. This denominator is going to multiply by 2, so we have to multiply the numerator by 2. Let's apply that. So your question is, one of these has 1 minus sign. Here? Just like you can analyze what the least common denominator would be, you gotta analyze what the least common denominator would be. So here I need 2 and a 3 became a 6. Here I need 1 minus sign and a 1 plus sign. To give this one to its common denominator, I had to multiply by 3. So to keep it balanced, I had to multiply the numerator by 3. This denominator you can multiply by 1 plus sign. So to keep it balanced, you have to multiply the numerator by 1 plus sign. This denominator is going to multiply by 2, so I multiply the numerator by 2. This one has this. I'm trying to exclude this, so I need to multiply this fraction. Now when you distribute those and combine my terms,
Where can I go from here? Since it's squared with the reciprocal, I can also make 1 side squared.
okay, so let's get that, because I think this is a little bit thicker than what you were trying to do. Sometimes you have to do that. So right here, if you've got something squared divided by itself, what does that come out to? Cosecant squared divided by cosecant is going to give you what? One is it's the exact same thing. Something divided by itself. Cosecant squared and cosecant are the same thing. What does cosecant squared mean? No, 2 cosecants would be 2 times cosecant. Cosecant squared means cosecant times cosecant. So if this means cosecant times cosecant, one of the cosecants can cancel out and it's going to leave you 1 cosecant. So your next line could be cosecant. And cosecant is the same thing as 1 over sine. Yeah. So you just need to have the work that shows that.
So on 9, we got to this 1 minus sine squared over 1 plus.
Okay. I want you to hear. I don't know what this is.
This is cosine squared is equal to 1 minus sine squared.
Oh, okay, that's it. Okay, so,
Now we are stuck.
okay, we're close. So down here, you see how we had the difference of 2 squares and factored it? Down here, this was the difference of 2 squares we could factor it. Well, 1 minus sine squared is the difference of 2 squares too. How would that factor?
Minus sine plus.
And then that cancels out. So I saw what you wanted to go away. That's how I had a hint about what to do. And then what's left behind is what you wanted.
You guys just did 9, right? Yeah.
Adding first, we have to write 1 minus sine is 1 over yeah.
It might not have.
Multiply this, top and bottom by 1 minus sine.
Yeah.
That's what I said.
I got that, yeah.
So when you just try to here, cosine times 1 cosine. Cosine times negative sine, which would be negative sine cosine.
Oh, yeah. See, that's where I was stuck, I don't know.
I mean, that should still cancel out the receiver, but then it's even a problem that this one you need to multiply by 1 plus sine, so if you distribute that, cosine times 1 is cosine, cosine times
Did you get
sine is
14?
cosine
You got 14?
That's been part of those two, but.
14 to 1 half.
Now. You can't multiply both sides.
So if I wanted to multiply both sides,
Negative 1, I'll make you there. The only thing that you're missing in your work, you get a common denominator to add these together. It's not just the 1 minus sine, you put the whole denominator, 1 minus sine and 1 plus sine.
you'd have to multiply this.
And if you boil that together, you're gonna get 1 minus sine squared, equals cosine squared, equals cosine squared, yes, so one of those cosines.
So they would have common denominators.
You did? Yeah. Now that I think about it, I thought it was
This one, have you tried this one compared to this one? I think they're kind of similar. You don't have to go through it next. Just like, talk about Pythagorean difference, a squared plus b squared equals c squared, a plus b doesn't equal c. So a squared equals b squared, b squared equals 4b. Get that one from earlier that we were looking at. That one, isn't it? Okay, so you split apart your fractions. So let me give you another suggestion. Even though I'm a big fan of splitting apart the fractions, if taking that approach gives you kind of a roadblock, sometimes just starting over and seeing if there's a different way might be easier. Because when I look at this numerator, I recognize that as part of the Pythagorean addition. But what is the goal of the plus? You can't just write the same thing. Okay. And what is cosecant squared divided by cosecant? Okay. And what is cosecant also written as? 1 over 3. There you go. So there's a different way that maybe you're just getting connected. Well, you've got a fraction divided by another fraction. So you can do this fraction times the reciprocal of that. When we divide fractions, we'll You've got 2 fractions here, 1 fraction there, so we get a common denominator.
You said multiply it by the reciprocal?
Dividing fractions is the same as multiplying by the reciprocal.
Wait, how would you multiply out that? Did you multiply?
Okay. I know I've been trying to give out some hints and stuff, but is there one that y'all would like to see worked out on the board? Number 9? Okay. So, if nothing else on 9, you could change this into cosines and this into sines and cosines. What I would probably do is see that I have a complex fraction, small fractions within a big fraction. So I really want to multiply this one by cosine to make those cancel. But that means I need to multiply this by cosine and this by cosine if I do that. It's all or none. This one's great because it got rid of one of my other small fractions. And if you take that approach, you end up with a cosine squared over those canceled, so that left a 1. Those canceled, so that left a sine. Are you okay with those steps so far? Whoever asked that one? Okay. Now, comparing this to this, I guess what's obvious to me is that I only want sine stuff. I don't want cosine stuff. So using the first Pythagorean identity, I could change cosine squared into 1 minus sine squared. And then, like a couple of the other questions, this is the difference of 2 squares. I've got 1 being squared on the left, sine being squared on the right. So if you make that change, those cancel, and what is left over is what's left over on the right. Is that enough? Okay. Again, it's not the only way to do it. So, But there's certain things, just changing everything to sines and cosines, dealing with the complex fraction, thinking about what I have versus what I want to know what to change, factoring the difference of two squares, and then if you get that far, then it's pretty obvious to see what to do. But similar skills to other questions, but every question is going to be different. So, okay, maybe one more for the board. Another one you've tried that seems harder than the rest.
14.
14. Okay, so 14 has two fractions on the left, one fraction on the right, so you need to add these fractions together. To add fractions, you have to get a common denominator. This guy has a 1 plus sign. This has a 1 minus sign. So the common denominator would be a 1 plus sign and a 1 minus sign. This guy needs a 1 minus sign, but you can't multiply his denominator by that unless you're willing to multiply his numerator by that. This guy has a 1 minus sign. He needs a 1 plus sign. Same thing. Multiply the numerator, you have to multiply, or the denominator, you have to multiply the numerator as well. And the purpose of getting common denominator is that we can write it as one big fraction and put these numerators over there. But I'm going to go ahead and distribute. I've got a cosine times 1 minus a cosine times sine plus a cosine times 1 and a cosine times sine. Those two are equal but opposite, so those cancel and go away. I've got two cosines on the top. Okay, so again, every once in a while I have to peek over to the right to see where I'm trying to go with this. Looks like I want only cosine stuff, so I need this sine stuff to go away somehow. So you could FOIL these, and it becomes 1 minus sine squared, which is a version of the first Pythagorean identity. That's equal to cosine squared, and cosine divided by cosine squared would be 1 over cosine, like that. So let me make one more plug here. If there's any of those basic identities that we ask you guys to memorize, you didn't memorize them yet, like the 3 Pythagorean identities, these questions are hard enough as is, but they become impossible if you can't see things like, I could change this to this.
Yeah.
Well, you haven't tried it yet. You need to start it first. Yeah, you should try it and see what you would do, see where you get stuck. 'Cause even if I do it on the board, it's good for you to know like the important step to review. And if you don't think about it first, then you don't have that.
Oh, yeah, thank you, yeah. I was gonna ask you about the end of class, but yeah, that'd be great.
I think these might be due today.
Yeah, no, that's what I was gonna ask you today, yeah. I forgot I had it.
That looks good so far. But when I look at this, it looks a lot like where we were at this stuff. The other kind of stuff. And we force those two together. I'm saying add your fractions together. Get a common denominator and add those fractions together.
Take 1 minus sine.
That's number 14.
Yeah, number 4.
Oh, okay.
So you took this and changed it to
How did you do that?
how did you get minus? Oh, okay. Like you took 2. I see that. Is that a percent in there? Like there's minus. Is that COS theta sine? Here. Why did you use that?
You're talking about right here?
Yeah. Oh, no. The two that cancel.
This was a negative cosine sign, and this was a positive cosine sign. So they just added 0. One's positive, one's negative, but they're the exact same thing otherwise. It's like, just like 3 minus 3 would go to 0 and you cancel them out.
No, I see what you're doing. I see what you're doing.
The problem is, like, I really emphasized last class, I split apart fractions. That works really good on the first couple questions, and we could do it on this one. But these questions can be kind of frustrating. It's not just one path to do. You know, the one thing that makes it easy may not be obvious to everybody. But take some practice.
It's quick to get to the score.
I need you to move that button, because you don't look like you're working on it. That's fine. There. Yes. I tried try to, I don't, not every single handout we do, I give participation points for, but I do try to mix in, just want to make sure that y'all are doing what you need to do and reward you with something.
This is the third line, so like if I switch it around, secant -1, equal 10 squared over half.
This is not secant, this is secant squared, so not the same thing. You can't do that on that one. You can change this to 1 over cosine and then divide those two to see what you get. And then I think you can maybe use one of those, but secant and secant squared are two different things. Okay.
Now, I don't know. So this is.
Oh, your little bit.
I know we need this one, because. Then,
Look at, you see your numerator, you see how both of these terms have a cosine squared? Okay, why don't you factor that GCF out?
so,
Maybe sine squared minus 1 over
Cosine squared times sine squared minus 1 over sine squared. Why don't you try writing that? Factor out a GCF.
this and that.
They both have a cosine squared, so you can undistribute it.
Oh, this.
Yeah.
And then, so -6 squared, that was like -4, right?
That doesn't look correct to me. If I distribute this, it should be the same as that. That doesn't look the same. Put a cosine squared out front. Make your parentheses and undistribute. So when you distribute what you write down, it should go back to the step before. There you go. Okay. It's all over sine squared. And cosine squared over sine squared could be thought of as
Cotangent.
good, where that cotangent square is coming from. And what's sine squared minus 1 equal to?
Sine squared, or something like that. Negative cosine squared.
I agree, something like that, but let's be a little more.
Cosine squared?
Look up here. Yeah, if I subtract this over, you're gonna have to subtract this over. So there's your negative and your cosine squared. So you did the hardest part. You just built this GCF. It looks more complicated though.
So once I get here, I just.
Yes.
This is done. Actually, this is pretty much done. I just have to write it out.
Because some of the sine people got angel.
This is.
It's negative.
Yeah, because it's sine minus 1.
See what's going on.
I think this is due today too, so make sure you get turned in. Okay, we are down to about 5 minutes, so I need to give a couple quick reminders here. There's a few things that you guys need to turn into Google Classroom, so if you haven't done it yet, you need to do that before class starts on Monday. We have our 4.3 quiz on Monday. I think there's 2 trig proofs, but most of the quiz is like the book assignment, so. but you'll have about 5 minutes. So you can find a stopping place.
A little bit. I was just by myself, but I'm gonna wait. You know what for?
No, we got pulled over going like 5 over.
Yeah, or something like that.
Yeah. He worked here for,
Just got angry because someone pulled him over going 5
maybe
over.
just 1 year,
Oh, I was the one who did.
but I've known her a long time.
I was the mountain up to the top, 5 over.